Hello, welcome to my channel. So I think this is my sixth video for the video tutorial on how to perform different statistical analysis using SPSS. So for today's video, I will show you how to perform analysis of variance, particularly OneWay ANOVA for independent measures design. Analysis of variance or ANOVA is a hypothesis testing procedure that is used to evaluate mean differences between two or more treatments or populations. So it may appear that ANOVA and t-tests are simply two different ways of doing exactly the same job, and that is to test for mean differences. So same with t-test, if the goal of the researcher is to determine if there's significant difference between factor groups, then you will use either t-test or ANOVA. In some respects, this is true. Both tests use sample data to test hypotheses about population means. However, ANOVA has a tremendous advantage over t-tests. Specifically, t-tests are limited to situations in which there are only two treatments that you have to compare or that need to be compared. The major advantage of ANOVA is that it can be used to compare two or more treatments. Thus, ANOVA provides researchers with much greater flexibility when it comes to hypothesis testing and interpreting the results. So I think this is the misconception about ANOVA, na you cannot use ANOVA if you only have two factor groups. Kaya din siya ng ANOVA. It's just that if you only have two factor groups that you have to compare, it is more advisable to use the t-test. Why? Because t-test is really designed for measuring the significant difference between two factor groups. So kumbaga talagang yung t-test ay naka-design for that, kung yun yung intention ninyo. Pero pwede pa rin gamitin ng ANOVA if you only have two groups. So one of the assumptions of using the ANOVA is that the data must be normal. So you have to perform first normality test to determine if you're going to use parametric or non-parametric tests. I have a separate video on how to perform normality test. Then you can just look that to my channel. So look for the video tutorial on normality test using Kolmogorov and Shapiro. So kailangan before we test or we test the hypothesis or answer the research question pertaining to inferential statistics, we have to perform first normality test. Let's say for this demonstration, we will compare the level of social entrepreneurial intention of different year levels. So for this case, we have first year, second year, third year, fourth year. And then you will perform normality test. Let's say lumabas sa first year, hindi normal yung data. Then second year, third year, fourth year, normal yung data natin. So our final decision is to use the non-parametric equivalents for OneWay ANOVA, which are Kruskal-Wallis test, Jonquier-Terpstra test, and median test. I will create a separate video on how to perform these non-parametric equivalents for OneWay ANOVA. You cannot use ANOVA if there's only there's only one factor group na lumabas na hindi normal. Ang decision ay to use the non-parametric. As I've said in my previous video, parametric test is very sensitive to outliers. So kapag pinilit nyo pa rin na gamitin yung ANOVA, kahit na hindi naman, kumbaga merong isang factor group na hindi normal doon, so most likely may problem na or mali na yung magiging results natin. So kailangan we have to follow the assumption talaga kung paano gagamitin yung mga statistical analysis. And I think ito nga yung parang naging practice na kahit na hindi normal yung data or tagang pinipilit natin na we have to use the parametric test kasi yung parametric test has higher statistical power. Higher statistical power kapag ang data ay normal. Pero yung mga parametric test natin, powerful din sila kapag ang data natin ay hindi normal. Kaya lang dun sa practice nga, ang laging iniisip dapat parametric ang gagamitin natin. Which is wrong naman. Wrong practice siya. So even if you have a goal to publish your paper, yung mga reviewer, chine-check nila if you perform normality test para malaman talaga na talagang gagamit kayo ng parametric or non-parametric equivalent ng mga statistical analysis na yun. So one-way ANOVA is also known as F-test. So one-way ANOVA, it means that we have one independent variable with multiple levels. In our case, we have year level, then year levels, then we have first year, second year, third year, fourth year. So it is appropriate to use the one-way ANOVA for that. So for the hypothesis, the null hypothesis will state that population means of first, second, third year, fourth year are the same. Walang pagkakaiba. So that is the null hypothesis. Whereas for the alternative hypothesis, may pagkakaiba doon sa level of social entrepreneurial intention ng first year, second year, third year, fourth year. Aside from performing the ANOVA, it is also important for us to use post hoc test. Kasi the limitation of ANOVA, sa bilang niya, there is a significant difference. So may pagkakaiba. Pero it cannot answer the question, saan nagkaiba? That's why we have to perform post hoc test. Ang kagandahan kay SPSS, kaya niyang ipakita yung results both ng ANOVA and post hoc test. For the post hoc test, we will use shift test, and it is a widely used measurement for post hoc test. So let's say, sabi nga natin, para mas ma-appreciate natin yung mga statistical analysis na di-discuss natin, i-apply natin siya sa real scenario kapag tayo ay nag-research na. So you're a researcher, then you have intention or you have a goal to identify if there's significant difference in the level of social entrepreneurial intention or SEI. This is our dependent variable then among different year levels of university students. So we have first year, second year, third year, fourth year. So out of this scenario, we can come up with our questions. There's significant difference in the level of social entrepreneurial intention among different year levels of university students. And our hypothesis is that there's no significant difference in the level of social entrepreneurial intention among different year levels of university students. So let's test now our hypothesis kung may pagkakaiba ba. So this is the command that we have to use in SPSS. So you have to open your file. For this demonstration, we will use the file for social entrepreneurial intention and then click Analyze, go to Compare Means, and look for one-way ANOVA. Then after that, move the dependent variable or the SPI to the dependent list box and move year level since this is the factor groups na, or these are the factor groups na i-measure natin kung may pagkakaiba to the factor box. Then click the options button, check descriptive homogeneity of variance. So we will click the descriptive if we have intention to show the mean and standard deviation. Pero maigi na rin na pakita natin yung mga descriptives niya. Kasi usually for the parametric talaga, it will use the mean and standard deviation. For the non-parametric, mga mean ranks and median ang ginagamit. Then click continue. And of course, we have to check kung may lumabas na significant or merong significant difference dun sa year level para malaman natin kung saan may pagkakaiba. We have to use post hoc. So click post hoc button, then look for shift. As I've said, shift is the widely used measurement for post hoc test. And then click continue and of course click OK. So let's perform that in our SPSS. Okay, so ito yung data na i-analyze natin. So I have a separate video for the demographic or the descriptive statistics. So syempre, before you run your data in SPSS, kailangan nyo nang ayusin yung sa data ninyo. So you have to assign labels in your nominal scale sa mga demographic characteristics or sa demographic profile dito sa mga characteristics natin. So kindly look for a video tutorial on descriptive statistics kung paano nagawa ito. So ito ay ready na para ma-run for OneWay ANOVA. So again, we will use, for our factor group, we will use year level, this one. So we have first year, second year, third year, fourth year. And then the social entrepreneurial intention. So we have to get first the overall mean. So doon sa video ko for the descriptive statistics, napakita ko rin daw kung paano kukunin yung overall mean. So ready na itong data natin to run for a one-way ANOVA. So first is go to analyze, then compare means, and look for one-way ANOVA, this one. So again, analyze, compare means, and one-way ANOVA. Then may lalabas na dialog box. For the dependent list, look for the overall mean of your variable or construct. So ito yung sa atin, overall mean. Click this arrow para mapunta sa dependent list. And for the factor, we have the year level. Ito. Then click this arrow para mapunta sa factor. Then first is click options. And click descriptive and homogeneity of variance test. Again, we will click descriptive if we want to present the mean and standard deviation. Continue, then go to post hoc. So para malaman saan ba may pagkakaiba, sa first year ba, sa second year ba. Kasi ang ANOVA, sasabihin lang niya ay may pagkakaiba. There's a significant difference. Pero hindi niya ma-identify saan may pagkakaiba. That's why we have to perform post hoc test. So these are the measurements for the post hoc. So meron tayong LSD, Bonferroni. Ang Bonferroni will be used if you will perform the non-parametric equivalence of ANOVA. So papakita ko rin yan doon sa video ko for the non-parametric test. Yung sa Kruskal-Wallis and Jonker Terpstra. May Tukey's, may Duncan. Pero sabi ko nga, we will use the the common measurement of post hoc, which is shift test. So click nyo lang yan. Then continue. So ready na to, okay na. Just click OK para ma-run niya na. Ayan. So ito yung sa descriptives natin. So again, for the parametric test, it will use the mean and standard deviation. So we have the mean of the first year, mean for the second year, mean for the third year, fourth year, and then yung total or yung overall mean nila. Then we have the standard deviation. And then we have the test of homogeneity, variance, then yung ANOVA, ito importante para malaman kung statistically significant ba or hindi yung data natin. And then of course, the post hoc test. So later we will compare or we will discuss the post hoc test. So i-paste natin yan sa PowerPoint natin. Magandaan din pala kay SPSS, madali natin maka-copy-paste yung mga table. Tapos, finalize na din natin. So aside from teaching or showing you how to perform the ANOVA, tuturuan ko rin kayo on how to present the results and make an interpretation of the findings na nakuha natin from SPSS. So, ang gagamitan natin ay descriptives, yung table for the descriptives, ANOVA, and of course, the post hoc tests. Okay, so we have here the results of our SPSS output. So we have the descriptive and then the ANOVA. So sabi nga natin, ito yung sa mean for the first year, second year, third year, ito yung mean nila, fourth year, 4.1771, and the standard deviation for the year level. Then, hanapin natin yung SIG. Again, SIG is equivalent to p-value para malaman if it is statistically significant, kung may significant difference pa. So, if our value is less than 0.05, less than, it means it is statistically significant. So check natin yung table for the ANOVA. So parehas naman yung sa p-value niya for between groups and within groups. Our sig is 0.001. So it means it is statistically significant. There is significant difference between the social or in the level of social entrepreneurial intention of first year, second year, third year, fourth year. Yun nga lang, hindi nito matasasagot ni ANOVA saan may pagkakaiba. So it is statistically significant. So pag ganyan, ayan. So 0.05, therefore there is a significant difference. So may pagkakaiba. Pero hindi masasagot ni ANOVA saan may pagkakaiba. Ang madalas ginagawa na lang ay yung sa mga researcher na wrong practice din na hanggang ANOVA lang sila. Tapos hindi sila nagpo-post hook. Basta sinasagot nila yung tanong, there's significant difference. Kung lumabas na talagang may significant difference or less than 0.05 yung sa p-value nila. Tapos hindi na nasasagot saan may pagkakaiba. Kaya yan, para kompleto, we have to perform the post hoc. So ito yung sa final output or final table natin. Sabi nga natin, di ba, dami nitong mga numerical values sa SPSS. So hindi naman lahat talaga ay pe-present doon sa research paper ninyo. So pwede kayo na mag-come up or mag-develop ng sa table ninyo yung mga final values na i-reflect ninyo on your research paper. So of course, we have the year level, first year, second year, third year, fourth year, yung size nila, population size. And then yung mean, atong mean nakuha yan dito. Yan, dito. Then the standard deviation, dito naman siya nakuha. Then yung F-test natin, tinan nyo siya doon sa ANOVA. Ayan siya. And then the degrees of freedom, 3 and 39, dito naman siya nakita sa ANOVA. And of course, don't forget to indicate the p-value. Yung p-value natin na 0.001, dito siya nakuha doon sa C. So kapag gumamit kayo ng SPSS para malaman if it is statistically significant, always look for the SIG or this is the p-value nga. Ayan. So sagutin na natin yung tanong kung saan may pagkakaiba. Ay, by the way, ito pala yung aside from describing the results, syempre you have to put you have to present the results and then make an interpretation. So pwede for the first, you can use this kind of format then. So for the first sentence, you have to indicate or state the title of your table. So table 1 shows that the mean of social entrepreneurial intentions of first-year students was 3.9624 with a standard deviation of 0.50155, while those second-year students reflected a mean score of 3.9336 with standard deviation of 0.42142. On the other hand, third-year students magnify the social entrepreneurial intentions mean score of 4.0420 kasi from 3.9, di ba, yung sa first year tsaka second year. Pagdating ng third year and fourth year, naging 4 na yung sa mean nila. So when the fourth-year students had a mean score of 4.1771 with standard deviation of 0.38812. And then, so these are the descriptions. Kung ano yung mga nasa table natin, i-state mo rin siya doon sa paragraph or doon sa pagpe-present mo ng results. And then yung last sentence natin would be the conclusion. So the results reveal that a significant difference exists in social entrepreneurial intentions among university students. So may pagkakaiba doon sa year level. Pero sabi ko nga, yung ANOVA, sasabihin lang niya, may pagkakaiba. Pero hindi niya masasagot yung tanong na saan nagkaiba. That's why we have to perform or we have to analyze the output in SPSS for the post-hoc test using shift test. So ito yung nakita natin, the table dun sa SPSS natin. And then, as I've said, para ma-check if it is statistically significant, just look for the sig value or the p-value. So sabi natin, if we have less than 0.05, oh, yan. Less than 0.05, it means it is statistically significant. So, yun ang hahanapin natin, yung mga less than 0.05 na p-value. So, first year and second year, 0.982 is greater than siya. So, hindi siya significant. First year, third year, 0.774, hindi rin siya significant. First year and fourth year, 0.3, significant kasi less than 0.05. Second year to first year, 0.982, not significant. Second year to third year, 0.456, not significant. So second year to fourth year, 0.002, ibig sabihin significant. Sige, lagay natin dito ha para hindi natin makalimutan. So first year and fourth year, significant siya. And fourth year. Then saan pa may significance? Second year and fourth year. Tsaka fourth year. May pagkakaiba. And then third year to first year, not significant din. Third year to second year, not significant din. Third year to fourth year, hindi rin siya significant. Then fourth year to first year, significant. Pero ito na rin siya, yung first year and fourth year. So hindi na natin siya isasama dito kasi parehas naman din dito sa una nating na-identify na may significant. And then yung fourth year to second year, ito na rin yan. So to summarize, may pagkakaiba between first year and fourth year. Then second year and fourth year. Then makikita nyo rin dito na yung asterisk, the mean difference is significant at the 0.05 level. So, nakalagay din dito, meron siyang asterisk dito sa mean difference. So, kahit nandiyan na isa-isahin, itong mga to, hanapin nyo lang kung saan merong asterisk. Doon makikita kung merong significant or the result is statistically significant. So, finalize na natin. Second year, fourth year, then second year, fourth year. To present the results of the post hoc, you can come up with this table. So, yung multiple comparison natin, yung first year to second year, first year to third year, first year to fourth year, second year to third year. Hindi natin pwedeng isama na yung second year tsaka first year kasi andito na siya. Oh. So, redundant na to include that factor group. And then second year and third year, second year and fourth year, then third year and fourth year. Napansin niyo wala nang fourth year to first year kasi andito naman na siya, na-address na siya dun sa mga previous factor group natin. And then create a column for the mean difference. Saan galing yung mean difference? Ito siya. Oh. Ayan. Hanapin nyo lang tong mga to. Yung first year tsaka second year, lagay nyo kung ano yung mean difference, 0.028, ayan siya. Then, lagyan nyo lang na asterisk to, yung sa mean difference. Tapos, lagyan nyo ng legend dito na significant at the 0.05 level. Then, pwede nyo rin siyang i-highlight, pero siguro okay na rin tong asterisk para mas formal tignan kaysa lagyan ng color pa. Then, for the presentation of the results and the findings, post hoc tests show that the significant differences in social entrepreneurial intentions among university students lie between first year and fourth year with mean difference of 0.21469 and second year and fourth year with mean difference of 0.24344 yan for the mean difference. So ito yung pagpe-present natin. So aside from stating that there's significant difference, we have to identify kung saan nagkaiba using the post hoc test. Okay? So thank you. So that will be the end of our demonstration on how to perform the ANOVA, one-way ANOVA using SPSS. So for my next video, I will create a video tutorial on how to perform the non-parametric equivalents of ANOVA, which are Jonquier-Terpstra and median test and Kruskal-Wallis test. Okay, thank you. And don't forget to subscribe.